Hello friends, today let's discuss some new topic. It's about structure of a molecule. Okay, what is a molecule? Friends, a molecule is a group of atoms. Okay, we discussed about atoms. By combining the atoms, we'll get a molecule. Molecule is an aggregation of atoms. Okay, so what is the structure of molecule? And this topic is about structure of molecule and also the types of bondings between the atoms. We discuss about both of them. Okay, the structure of molecule. What is a molecule? A molecule is a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. Basically, a chemical reaction consists of molecules. The molecules react with each other to overcome a chemical reaction. There will be some initial compounds, then the reactants form the products. So all these happens in between the atoms which are in the form of molecules. When we disintegrate the molecule, we will get an atom. Suppose we take in a molecule like H2O, water. So a group of atoms bonded together representing smallest fundamental unit of a chemical compound that take part in a chemical reaction was a molecule. Okay, so we take in a H2O molecule. It's a tetrahedron and the angle between two H atoms was 104.5 degrees as we noted here, and there are two lone pair electrons were present. Okay, so usually why, okay, one question here is why the water molecule was a bent structure. The answer is due to the polarity. Means here the O is negatively charged and H is positively charged, means polarity. I'm discussing about the polarity. Due to the dipole moment, means due to these ionic characteristics, the H and H will repel with each other, and also lone pair of electrons also repel with each other. Okay, they were at certain angle. Even the lone pair electrons, you can see here, it is 109 degrees. Repulsion between lone pair is greater than repulsion between hydrogen atoms. Okay, here the repulsion between these lone pair electrons, there are two lone pair electrons, okay, were greater than the repulsion between these hydrogen atoms. So this H2O molecule, why it is bent in structure, is due to the dipole moment or something due to the polarity, because O is polar. In case of polarity, that is O is more, oxygen is more electronegative. So these electronegative values, electronegativity describes the structure of an atom. No, not an atom, structure of a molecule. Sorry. So due to the electronegativity, due to the polarity, electronegativity which gives rise to polarity, which is by dipole moment. So totally dipole nature exhibits the structure of atom. No, not an atom. Again, sorry. It's a molecule. The structure of molecule. The atoms are arranged in a manner to form a molecule, but how the atoms will arrange was a part of so many forces, so many things in the molecule. Okay, let's go for polarity. We discuss a detail about polarity. So because of the polarity, a molecule of water in a liquid or a solid state can form up 4 hydrogen bonds. What are these hydrogen bonds? These are hydrogen bonds between the other water molecules. Okay, between the other water molecules, these were the hydrogen bonds. Why they formed? So usually we take a glass of water. In the glass of water, the water consists of millions of water molecules. They were all attached with some force. Those forces are nothing but due to the hydrogen bonds. Due to this lone pair of electrons, okay, due to this polarity, okay, the hydrogen bonds, 4 hydrogen bonds with the neighboring molecules are formed. Due to this thing, the water in any state, suppose we take a solid, liquid, or anything in the vapor form also, the water, the bond with 4 other water molecules. Hydrogen bonds are 10 times as strong as van der Waals forces that attracts molecules to each other in most of fuels, so most of the liquids. So why, the other question is why the boiling point of water is 100 degrees Celsius. So because of the hydrogen bonds. Because of this, to break that hydrogen bond, we require some energy. To break that molecule into atoms, we require some energy. So we are giving that energy in the form of heat to boil water into water vapor. So because of the polarity, totally it's due to the polarity, a molecule of water in the liquid or state can, any state can form liquid or solid state, not any state. In the vapor state it can form, liquid or solid state can form up to 4 hydrogen bonds. Again, as we discussed, why it is a molecule structure is mainly based on polarity. Why polarity is occurred? Because of the electronegativity of those atoms. Different bonds also we discussed in the further of this thing. The bonds also arise, different types of bonds, the covalent, the ionic, these all are due to the electronegativity differences. Electronegativity plays a major role in formation of molecules, formation of bonds, and also the shape and structure of the molecules. Okay, the shape, structure, everything was there is interrelated to everything of this molecule. Okay, the water molecule, a commonly used example of polarity. 2 charges are present in negative in the middle, red shape, and a positive charge at the ends, that a blue shape. So there are 2 charges with a negative charge. This is the negative charge as I am rounding up, and there are 2 positive charges. These are nothing but hydrogen bonds. This is nothing but an oxygen. Okay, I am writing here oxygen. This is the oxygen atom in the middle, red one, and these 2 are hydrogen bonds. Okay, indicating the polarity. Why? Because they can't integrate in the molecule, cannot summon up. So the molecule is V-shaped. To form a molecule in a stabilized structure, there is the atoms attains shapes. So shapes are very critical for the stability. Next we go for dipole moment. As we know, the dipole moment also, which was due to the dipole moment only the polarity occurs, is the quantity that describes the two opposite charges separated by a distance. Okay, this is one example, positive charge, we taken a negative charge separated by r distance. The dipole moment is calculated as mu is equal to q dot r, q into r. Separated charges, distance between charges, separated charge, q into r. Q means the charge and r is the distance. So as an increase of H2O molecule also, so in case of H2O molecule also, dipole moment which developed due to the polarity of molecule resulted the bent structure. Note this point, why H2O molecule attained bent structure. Okay, the answer is about due to the polarity. Very, very critical thing. So we represent molecules in many forms. Okay, let's discuss about several forms of representation of a molecule structures. Okay, one is the Fischer projection in case of glucose or fructose, sucrose, or those things we use Fischer projections. So we can use any form, it's not about matter which form, but we can represent in any form. So this type is the second one is, this is first one, the second one is bond like formula. Suppose this is a formula of vitamin A, and the third one is Kekulé structure of benzene. That is the circular structure, means ring structure, ring type structures. These are called ring structures, Kekulé structures of benzene. So the fourth model is balanced model, which is very famous. Balanced model. Okay, balanced model also very good representing model, because it's a 3D model. Actually it's a three-dimensional representation of a molecule generally. It's a balanced model. Okay, so balanced model, generally to represent anything in a three-dimensional, we use balanced model. And these are Lewis structures, means dot structures, Lewis structure. And the last and final one is fifth one, Lewis structure of representation of the molecules. And next we go for the types of chemical bonds. Okay, we know that the atoms aggregate to form molecules. So how they form? Because how they form? By a chemical bond. A chemical bond is very important and essential, very essential, very to form a molecule. Okay, to form a molecule, generally a chemical bond is essential. A chemical bond is a lasting attraction between atoms, ions, or a molecule that enables the formation of a chemical compound. Note this point. So chemical compounds, to form chemical compounds. Every molecule in the universe, the atoms form the molecule with the help of chemical bond only. There is something in between the two atoms. What is that? In between, this is an atom, suppose, and this is an atom. In between those atoms, what were present? It's nothing but a chemical bond. Chemical bond is very essential. Okay, to form a molecule. Note that, to form a molecule, chemical bond is very essential. There are two types of chemical bonds. One is stronger bonds or primary. They are also called as primary bonds. Okay, as we know, the stronger bonds or primary bonds. And the second one is weaker bonds or secondary bonds. The primary were nothing but covalent bond, due to the covalent bond which is formed due to the sharing of electrons between the atoms. Yes. And the ionic bond, which is formed due to the complete transfer of electron from an atom to another atom. Complete. Here, in case of a covalent bond, it's a weaker bond because due to the sharing of electron. In case of ionic bond, it's a stronger bond, very stronger than covalent bond, due to the complete transfer of an electron from one atom to another atom. Suppose example is in case of covalent bond, the example is some methane, some organic molecules. And in case of ionic bond, the example some metallic bonds like sodium chloride, salts. Mainly the ionic bonds are formed in case of salts. And then the third category is metallic bonds. The metallic bond is due to the delocalization of electrons. Suppose we take an example like iron. The formation of iron, the strength of iron is due to the metallic bonds. And also conduction of any current, electricity or any type of heat is due to the metallic bonds. And reflection of a light by a metal, the shiny nature, why we get shiny nature for metals, reflection of a light by a metal is also due to the metallic bonds. Metallic bonds reflect the light. And when you go to the other category is secondary. Okay, there were dipole interactions, London dispersion force, or they were also called as van der Waals forces. We were very famous of this terminology. We very know the van der Waals forces. Van der Waals forces, they are the weakest forces. And also the other thing is very crucial thing is the hydrogen bonding. As we discussed in case of H2O also. H2O, in case of H2O, we discussed the hydrogen bonding. H2O also, because due to the hydrogen bonds, each water molecule will bond with other four water molecules by hydrogen bond, so that the strength of a water remains something more peculiar. To boil water, we need 100 degrees Celsius. So we need some energy to break that hydrogen bonds. Hydrogen bonds are more stronger than van der Waals forces. Okay, this is a very important point. We know that hydrogen bonding is more strengther than van der Waals forces. Okay, next we go for clean and clean classification. One is in case of primary bonds or stronger bonds, we classify the stronger bonds into covalent, ionic and metallic. Let's discuss briefly what is a covalent bond, what is an ionic bond, what is a metallic bond. So before discussing that, let's discuss what are primary bonds. What are primary bonds or stronger bonds? What do you mean by a stronger bond? Let's discuss. I have a question in the mind. The stronger chemical bond are the intermolecular forces that hold atoms together in the molecule. Okay, the atoms will hold together in the molecule. A strong chemical bond is formed from the transfer or sharing of electrons between atom centers and relies on electrostatic attraction between the protons in the nuclei and the electrons in the orbital. So, due to the transfer of electrons results an ionic bond. There's a classification of stronger bonds. Due to the sharing of electrons results covalent bond. Due to the electrostatic attraction results metallic bonds. See, in the definition only we got the classification also, ionic, covalent and metallic bonds. And the type of strong bond differs due to the difference in electronegativity. Thus we have to know here how the electronegativity plays a very crucial role in the formation of bonds. Types of strong bonds also, electronegativity plays a very crucial role. Based on electronegativity, the polarity of atom exists. Based on these two issues, the structure of a molecule, the nature of a molecule, the persistency of the molecule in the universe totally changes. Very keen thing we have to know when we go across the structure of a molecule, that electronegativity was very keen thing, because it implies in many ways, like polarity, like structure, every aspect it is related. Okay, very when we want to understand a molecule structure, we know that we want to know the electronegativity of atoms of that molecule. So based on that, the structure will be, and based on that, the bond, the type of bond will be, everything is connected. Okay, the type of strong bond, as we discussed, that differs due to the electronegativity of the constituent elements. What is an electronegativity? This is the definition of electron. It is the ability of atom to attract shared pair of electrons to itself. So it's an ability of an atom to attract the shared pair of electrons towards itself. A large difference in the electronegativity results more polar character, more ionic nature. More difference results more stronger bonds, means ionic bonds. Very interrelated concept it is. Okay, let's discuss ionic bonds. The first stronger bond, ionic bond. So ionic bond generally is a type of electrostatic interaction between the atoms have a large electronegativity difference. As I discussed now only, large electronegativity difference results stronger bond, which nothing but an ionic bond. See which type of bond have to form also related to electronegativity. That's what I said. Electronegativity is very important. So there is no precise value that distinguishes between ionic and covalent bonding, but the electronegativity difference over 1.7 likely to be ionic, and the difference is less than 1.7 is likely to be an covalent for this. So ionic bonding commonly occurs in metallic salts, as we discussed, like NaCl, sodium chloride. Okay, here we can observe that NaCl, the sodium chloride, in Na the atomic number is 11, and in the Cl, chloride, the atomic number is 17. So the Cl molecule have to attain a stable configuration. For that, the Na donates one electron an electron to Cl. Okay, Na donates 1 electron to the Cl. Okay, here we can see that when we bind the Na plus Cl, it's a chemical reaction occurs and the formation of NaCl. So in the outer shell, this electron I am marking in the pink. The yellow atom is nothing but an electron. It's not an atom. The yellow one is an electron. When this yellow one is completely transferred from Na to Cl, Cl outer configuration to attain Cl 18 and Na 10. The totally it's an ionic bond resulted. Why ionic bond? Ionic bond resulted due to the complete transfer of an electron. See, here we have to observe that the yellow one in the Na completely transferred to the Cl. Okay, the yellow one completely transferred. See, the yellow one here completely transferred to the Cl. So the ionic bond is formed. The electron was donated by sodium to the chlorine. So the NaCl, sodium chloride, is formed. This is the nature of ionic bond. Mostly metallic salts, mostly salts form ionic bonds. Okay. Next we discuss about the covalent bond. What is a covalent bond? Generally we know when we hear the word covalent bond, it's nothing but due to the sharing of electrons. But in case of ionic bond, it's a complete transfer of electrons. So covalent bond is common type of bonding in which two or more atoms share valence electrons more or less equally. Less equally. This term have to note. More or less equally. The simplest and most common type is a single bond in which two atoms share 2 electrons like this. Suppose a carbon CH3 molecules. This is a single bond. And other types of include the double and triple bond like double bond, triple bond. Double and triple bonds also can happen mostly on the organic molecules. Organic chemistry full of nothing but chemical covalent bonds. Covalent bonds arise due to the sharing of electrons. Here we can visually see how electron from a hydrogen is a red one, and in case of electron from a carbon is a blue one. Those were shared by a carbon. Okay, it's nothing but a formation of CH4. Okay, 4 covalent bonds. CH4. It's nothing but a methane. Okay. Covalent bonds were also strong bonds. They're formed by sharing of electrons with each other, more equally or unequally, and also they can form a single bond like this or a double or triple bonds also. No problem. There exists alkanes, alkenes, and alkynes. We studied that. Next we go to another category of strong bonds, that is metallic bonding. Usually a metallic bond is a critical thing. Metallic bond is a type of chemical bonding that arises due to the electrostatic attractive force. Electrostatic attractive force between conduction electrons. Okay, between conduction electrons in the form of electron cloud of delocalized electrons and positively charged metallic ions or metal ions with metal ions. It may be described as a sharing of free electrons among a structure of positively charged ions or cations. Metallic bonding accounts for many physical properties of metals such as strength, ductility, thermal and electrical resistivity and conductivity, opacity and luster. Usually all metallic characters due to the metallic bond. Suppose here is an example. See, light consists of a combination of electrical and magnetic fields. We know that light basically it consists of both electrical and magnetic waves fields. Okay, the electric field is usually able to excite an electric response from electrons involved in metallic bonding. The result is that photons are not able to penetrate very far into the metal. They are typically reflected. Okay, Suppose we take a silver. Okay, silver we know Ag. When a light falls upon the silver, the light rays, the light energy usually reflected by the surface of the silver metal by the metallic bonds in the silver metal. So we see a shiny nature of the silver metal. Why we get shiny nature? We get generally a shiny appearance of the metals and some metallic structures usually. Why we get shiny nature? Because of the reflection, because of the elasticity of the energy, of the light energy which reflects by the metallic bonds. So many properties of the metal, many things is due to the metallic bonding, which is resulted due to the delocalization of electrons. That's very important, delocalization of electrons. Okay, next we go for weaker bonds. Weaker bonds, the second section is weaker bonds, weaker things or secondary bonds. One is dipole-dipole interaction. Why dipole-dipole interaction occurs? Due to the large difference in electronegativity. Again, electronegativity plays a very crucial role in this. Two bonded atoms will cause a permanent change in separation of dipole in a molecule ion. Two or more molecules or ions which permanent dipoles can interact with a dipole or dipole interactions. The bonding electrons in a molecule or ion with an average of closer or more the electronegative atom more frequently than less electronegative one, giving rise to partial charges on each atom. So dipole-dipole interactions is nothing but usually when we take okay, suppose we take H2O molecule only. Again, here this is a O atom, this is a H, this is a hydrogen, this is a hydrogen. Okay, we will get a partial charge like this, negative in the oxygen atom and positive. Why we get these charges? Due to the dipole-dipole interactions. Dipole-dipole interaction is nothing but, so due to the electronegativity, it has a bent shape. Okay, bent shape of H2O. We know that previously we discussed. So each atom carries some partial charge, so which causes a dipole and dipole interaction. Dipole is nothing but one positive and one negative is nothing but a dipole. Two poles, one is positively, one is negatively. Okay, there are some interactions which are helpful for molecule stability, molecule interaction with other molecules, and so on. So the second one is very important, hydrogen bonds. Again, we take an H2O also. H2O, as we discussed before also. Now I am circling up the H2O with the two H2O molecules. Here there is a possibility of hydrogen bond. Due to the hydrogen bond only, two water molecules can hold up with each other in a huge water molecule thing. Okay, when we take a glass of water, lot of water molecules are there. So on the thing, usually two or each water molecule can hold up to 4 water molecules. So each water molecule H2O can hold up to 4 H2Os by hydrogen bonding. Okay, due to this nature, basically the boiling point is 100 degrees Celsius. So we have to supply energy to break the bonds and to free up those H2O molecules into water vapor. Okay, so as I written here, so through both the not depicted in a diagram, water molecule, two active pairs, so the oxygen atom can interact with two hydrogen atom to form a two hydrogen bonds. So other intermolecular hydrogen bonding is there. So which is responsible for high boiling point of water. So note this, high boiling point of water. Why 100 degrees Celsius? Why? Because due to intermolecular hydrogen bonding of one H2O with 4 H2Os. So all are intermolecular bonded with hydrogen bonding. And next other category is these are the very weaker forces London dispersion forces or van der Waals forces. The London dispersion forces arise due to instantaneous dipoles in the neighboring atoms. So electronic cloud was there, and though the negative charge of electron is not uniformly around the whole atom, so it is distributing everywhere. So there is always a chance of imbalance. So a molecule, it can undergo imbalance. So due to the imbalance and due to the electron is not uniform around the whole atom, the small charge will induce corresponding dipole in nearby molecule, causing an attraction between the two. The electron then moves to another part of electron cloud. This we have to note. So there is some distribution of electron cloud between the atoms. Okay, thus results London dispersion forces or van der Waals forces. The electron distribution around the atom or a molecule undergoes fluctuations in time. These fluctuations create instantaneous electric field which are felt by other nearby atoms and a molecule, which in turn adjust by spatial distribution of their own electrons. Okay, the net effect is the fluctuations in the electron positions in the atom due to correspondence redistribution of electrons in other atoms, such as the electron motions become correlated. So usually due to the electron cloud imbalance of an atom results London dispersion forces or van der Waals forces. Van der Waals forces are weaker forces. When we can see everywhere the van der Waals forces, they are weaker. They usually control some spatial shape of a molecule. So all forces, all things where results the shape of molecule or the structure of molecule. Hence, finally I conclude that the structure of molecule is nothing but the group of atoms being connected with a chemical bonds or bonding, which were due to generally how these whole molecule structure will depend upon. One is polarity which arises due to the dipole moment, dipole nature, and these were arise due to the electronegativity of individual atoms. Okay, so finally this electronegativity was a crucial role in the formation of structure of molecule and the type of bonding between atoms. Okay, whether the bonding is to be ionic, whether the bonding is to be covalent. If greater than 1.7 electronegativity, they are ionic, and if it is less than 1.7, they are covalent. Also decided by electronegativity only. So electronegativity plays a crucial role in the structure of a molecule. So finally, this is a thing about a small session about the structure of molecule and types of bonding between atoms. So signing off, he was Madhu. Bye, take care.